Okay. Hello. This is a parallel project. I have a new project, very simple, with I hope you can see it, with PIC 12 F508. It's a PIC microcontroller, and with 3 LEDs. I've seen it. I've seen this in a game, and I like it. This little blinking sequence. And what I did here, these are the interface, if you want, the front panel designs. So this is a version of a front panel design, and these ones as well. Probably I will make it as a box, a little box with the chip in it. I'm not sure yet, but the most important, the front panel. Maybe this, maybe this. I want to keep it very, very simple, very cool, and very cool. And I'm not sure how much you can understand from this circuit here. And where are you? Like that. I hope it is focusing. Let's see, like this. I'm not sure how much can you understand from here. This is actually the components displaying how they will stay there. And actually, let me focus again. Okay, so this is the chip, the PIC microcontroller, and this one is from a board. Actually, I took it. Come on, focus again. Okay, so they are 2 LEDs on a single board with its own resistor there. The little black thing, it's a extremely tiny resistor, but it's there and is for both of those LEDs. So I will use this component here. Actually, I have an idea of using. Let me focus again. Okay, I expect to receive RGB lights, LEDs. I think I took 100 with $1 or something from eBay or AliExpress. I don't remember exactly where, but they are on the road. But that will be another project. Until then, these 2 LEDs, they are actually 2 LEDs inside there, like this tweezer, one on the right and one on the left, 2 LEDs like that, and linked to that resistor there, and that's it. And you can see there another 2 blue LEDs. They are the same color and the same color, and that's what you are seeing here actually as a square. So this is a square, and this will be also a square if I'm putting them close each other. So these squares are these LEDs. This is green and orange, I think, and this will be the 2 blues that will form a square. So let's call it 1 blue and 2 different colors. And this other 4 LEDs, these other 4 LEDs on the margins will be, and I didn't decide on a color, but probably will be a very dim white, constant white LEDs, always open. But only this color LEDs will change, drive driven by that PIC microcontroller. I hope it's clear enough. And this is actually the actual circuit. Let me focus on this. Okay, so this is my plan. But these are the 3 pins from the PIC, GP0, GP1 and GP2, and from 0 pin, which is pin 7 actually, 6 and 5, but from GP, let's call it 0, 1 and 2 for the moment, and from 0 they will get out 2 wires, one wire to the multicolor LED, let's call it multicolor, and this will be the blue color, and then to the white, and this one as well. So these two are lighting all the time, but very dimly through this 20 kilo resistor. And then I will add a little bit of power to the LEDs. They will get a little bit brighter, these white LEDs, when one of these 2 LEDs will get activated by pin 0 or pin 1. That's why you have you see here a little bit of jungle of wires, and that's actually my problem. I will not discuss this part because it's the mirror of this one, but the difference is that those 2 LEDs are in parallel, and they are driven all together in the same time as a single LED, but I put 2 to make a square basically. So from the last pin, from here is, but these 2 pins and these 2 LEDs, these 2 pins are driving 2 separate LEDs, groups of LEDs actually, 1 or 2. Actually 0 will command this LED and 1 will command the other LED, but in the same time will give power to these whites, a little bit more power, like a bit of blimp. Hello, this is an update. I modeled on the breadboard exactly the same circuit as intended. I've also updated the circuit on the paper here. I've added these 2 diodes, actually 3. I inversed the pin numbers to correspond with the program inside the PIC. And if I didn't add these diodes, the positive voltage that was flowing through that resistor and keeping lit these 2 white LEDs was flowing through that 10 kilo resistor, through that point, and then flowing through this LED and to the ground. So that's and the same here as well, was flowing through that LED and keeping them open. Depending on the sensitivity of the LED, the green LED was very sensitive and he was staying a tiny bit lit. The orange one is not that sensitive, so it wasn't lit at all. But that's what happened, and by limiting the positive voltage through those diodes is keeping lit these 2 white LEDs, and when the impulse is coming through one of those pins, is brightening a little bit more these 2 white LEDs, and is doing a good job. That's it with the update. Let me close the lights a little bit because it's good to see it. Okay, so I will cover, as you can see, the pay attention to the white LEDs. They are the same intensity right now. I changed the values actually on the breadboard. I should have updated the sketch, but I didn't. So these are actually 100 kilo here for the white LEDs because they are super bright, and here are 20 kilo from the pin, from the diode to impulse, to give a little bit impulse to the white LEDs. So if I'm putting my finger here, check that intensity, how they are very close, very close as intensity goes. So that's I'm very happy with the result. Yeah. So those white LEDs intensity when they are staying lit is the same, and when they are getting the impulse, they are getting a little bit more brighter as well for the blue LEDs. Let me actually show it like this. You see, the white LEDs here are also getting a little bit brighter, the same as those. Yeah, let me do it like this. So yeah, that's cool. That is very cool. Yeah, it's kind of these two LEDs are kind of emanating the light everywhere, and you believe these LEDs are not actually lighting, but they are. And let me do it like this, maybe. No? Yeah. Yeah, it's a nice effect. It's an interesting effect. I hope it will look nice on the actual board itself. Okay, this is it, and see you later when I will actually build this. Okay.